Let's start with problem number 4 here. We want to sketch and discuss the given parabola. It's x squared equals negative 8y. So this we can write as x squared equals 4p times y, or 4c times y rather. And so that means that 4c is equal to negative 8, which means c is negative 2. And so this will tell us that it's going to open down and that the focus is 2 units away from the vertex. And so is the directrix. So because this is opening down, the vertex is going to be at 0, 0. So the directrix will be above it 2 units. So that's going to be the line y equals 2. And the focus, we're going down 2. Like that. And so now we just need to graph this. So if I just pick a point, x equals 8, we have 8 squared equals negative 8y. So that's 64 equals negative 8y. Y is equal to negative 8. And the same is true if I plug in x equals negative 8, because this is symmetric about the y-axis. So it looks something like that. And so the vertex is 0, 0. The focus is at 0, negative 2. Directrix is at y equals 2. The length of the lattice rectum, we'll call it LR. That is the absolute value of 4c, which for us, that's the absolute value of 4 times negative 2, which is just 8. And then it's symmetric about the y-axis. Okay, let's move on to question number 15. Okay, question 15 says we have vertex at 0, 0. It's symmetric about the x-axis, and the length of the lattice rectum is 5. So we want to come up with the equations of the parabolas. So let's draw this out. 0, 0. The symmetry is on the x-axis. So that means there's two options. It could either open up to the right or it can open up to the left. So we need to consider both options. And we know that the form it's going to have is y squared equals 4c times x. Now, 4c represents the length of the lattice rectum. So we're given that as 5. That means we can replace it by 5. But if I just leave it as positive 5x, that's going to be the one on the right. So to get to the one on the left, I have to do a negative 5x. So this problem has two answers. Y squared equals 5x and y squared equals negative 5x. Moving on to number 20, we have the vertex again at 0, 0. It contains the point negative 3, negative 4, and negative 3, 4. So we want to find the equation again. So let's graph this. This one we only have one option really. There's no other parabola that will go through these 2 points. So we just need to figure out what it is. Because this opens up to the left and has a vertex of 0, 0, we know it's going to be the form y squared equals some negative number, call it a, x squared. And so we just need to figure out, negative ax. We just need to figure out what a is. So the best way to do that is to plug in a number. So let's say we plug in x equals negative 3, y equals 4. So that gives us 4 squared equals negative a times negative 3. 16 is equal to 3a. So a is equal to 16 over 3. So now this will go back in here to get a final answer of y squared equals negative 16 over 3 times x. Moving on to question number 23. So we want to find the equation of the parabola with focus at 0, 0, and directrix is x plus y equals 4. So let's graph this. So our focus is f at 0, 0, x plus y equals 4. So it's basically this line right here is a directrix. And so this is an unusual parabola. It's like a slanted. So what we need to do is just use a definition, which says that any point of the parabola, let's just say the parabola looks something like this. We don't really know. Any point on this parabola is equidistant from the directrix and the focus. So that's what we need to figure out. So first, let's figure out the distance from this point. We'll call it x comma y from the focus. So what's the distance between the focus and the point? That has to equal the distance between the point and the directrix. The distance between the focus and the point is very easy because all you have to do is just use the distance formula. So that just turns into x squared plus y squared, and the square root of that. Because this is the point, the focus is at 0, 0. Now the distance between the directrix and a point, this is a distance between a point and a line. So in general, so let's do that on the side here. So let's say if you have ax plus by plus c is our line, and x comma y will be the point, the distance becomes the absolute value of a times x plus b times y plus c all over the square root of a squared plus b squared. So this is just a formula you need to have memorized in order to do this. So for us, a is given to us as 1, b is also 1, but I need to bring the 4 over to get x plus y minus 4 equals 0. So c has to be negative 4. So we're just going to plug it in here. We have the absolute value of a, which is 1 times x plus b times y. B is 1, so that's just y, minus 4, all over the square root of a squared plus b squared. So that's square root of 1 squared plus 1 squared, which is square root of 2. And so we just need to get an equation here. We're not trying to solve for x or y or anything like that. So in order to solve this, you want to be clever by taking advantage, by getting rid of the square roots first of all. So how do you do that is you square both sides. And the nice thing is if I square the absolute value of x plus y minus 4, that just, the absolute value goes away, and then you just leave that as a square. So then I can multiply both sides by 2. And then I just need to distribute the exponent here. So you have 2x squared plus 2y squared is equal to x squared plus 2xy plus y squared minus 8x minus 8y plus 16. Bring everything over to the left and end up with x squared plus y squared minus 2xy plus 8x plus 8y minus 16 equals 0. That's the answer. So you may be wondering, how did I do this thing so fast? So let's talk about that. So this is pretty simple. Just think of it like this. You need to square everything. So square everything on this side. X squared, y squared, 16. Okay, that's step 1. Step 2, make sure you multiply the diagonals now. X times y, is xy, but you want 2 copies because you can also go backwards, right? Because you could do this way. But to keep it simple, we'll just focus on the left to the right. So then xy is done, y, we go to -4. So that's -4y, which is -8y. And then, actually, we forgot to do this one. X times -4. That's -4x. Double is -8x. So that's kind of how I think about it. Okay, let's move on then to question number 25. We want to find an equation of the parabola with focus now at 1, 1. Sorry, this is a wrong question. Find an equation of the line tangent to y equals x squared. At the point 1, 1. So basically, you have your equation y equals x squared, and you have a line that goes through this point 1, 1. It's tangent to the parabola. So we just got to figure out what's that tangent line right there. So let's start with what we're given. The tangent line goes through the point 1, 1, but the slope is unknown. So we're going to say the slope is 1. The slope is m. So if you use point slope, we have y minus 1 equals m times x minus 1. And so this line has to intersect y equals x squared. Right. So think of this as like a system of equations. If it's going to intersect, then these two equations have to be equal at that point 1, 1. So the way we're going to solve this system is by making a substitution. We're going to take our y equals x squared, plug it in here. So instead of y minus 1, it's going to be x squared minus 1 equals mx minus m. Bring everything over to the left and get this. Now, at this point, I just care that the line intersects the parabola at one point. I want one solution. This is the key here. What will guarantee me one solution? Well, that's if the discriminant is 0. So the discriminant of this guy. So discriminant, we said in algebra 1 was b squared minus 4ac, which for us, b is negative m, so m squared minus 4 times ac, that's -4 times -1, which is just positive 4. Wait a second. B squared minus... No, sorry, this is wrong. This is C, by the way. C. This is B, this is C, this is A is 1. Okay, so let's try that again. So B squared is M squared minus 4 AC. So C is M minus 1 like that. So you want that thing to be 0. So we have M squared minus 4M plus 4 equals 0. And then you factor this out. M minus 2 squared equals 0, so M has to equal 2. So then now this M equals 2 can go up here. So you have y minus 1 equals a slope times x minus 1. And if you want, you can simplify and get y equals 2x minus 1. So either one of these should work. So that'll be your tangent line. Okay. Finally, question 38 says an automobile headlight has a parabolic reflector that is 6 inches in diameter and 3 inches deep. How far from the vertex should the light bulb be placed? So let's draw this out. So think of this as a parabola, but it stops. It doesn't go to infinity. And so this distance here is 6. And that's the diameter, and it's 3 inches deep. So that's 3 inches. Think of that as like the height. And so we want to see how far from the vertex should the light bulb be placed. This is going to be the focus. So this word problem is basically asking you, what is the focus of this parabola? So we want to be smart about this and just treat it as a parabola with the vertex at 0, 0, because that's by far the easiest thing to handle. And we're moving 3 units to the right and left, right? Because the 6 can be broken up into 3 and 3. It's symmetric about the line that goes to the focus. So in this case, it'll be the y-axis. So has to go through these points, 3 and -3. And our focus is going to be somewhere inside here. So now it's a very easy question, because if I could find the equation of 4cy equals x squared. So then if we plug in x equals 3, y equals 3, we get 12c is equal to 9. So c is 9/12, which is 3/4. So that means that the focus is 3/4 above the vertex. So that'd be 0, 3/4. So to answer the question is asking how far from the vertex should the light bulb be placed. The answer is 3/4 inches.